This is part 3 of section 5.5. I want to solve the equation 2 cosine of x minus pi over 4 plus 1 equal to 0. And we're supposed to find all solutions on the interval 0 to 2 pi. Now, this is the first time the argument of our trig function has been more complicated than just an x or a theta. And it does add a level of difficulty, but it's still not that bad. The first thing I want to do is I want to get this whole cosine by itself. So subtract 1, divide by 2, and you have cosine of x minus pi over 4 is equal to negative 1/2. Now I want to find inverse cosine of negative 1/2. Even though that's more complicated than just an x, I still want to find out what this is equal to. And it is 2 pi over 3. Okay? Now, what we've been able to do before, when we had just an x or just a theta, is we were able to go theta equals x equals. Here, we don't get to do that. We have to write x minus pi over 4 equals. And then we're going to have a little bit more arithmetic or algebra to get done. But this part is the same as this. We do the right-hand side the same way. So you take your alpha and you add 2n pi to that because it is cosine. Or x minus pi over 4 is equal to, since this is cosine, we do 2 pi minus our alpha, which is 2 pi over 3, and then we're going to add 2n pi to that. Okay, so we want just x, so add pi over 4 to here. We're going to need to get a common denominator and combine, and you get 11 pi over 12 plus 2n pi. Here we have x minus pi over 4 is equal to, that is 4 pi over 3 plus 2n pi. Now add pi over 4 to both sides, getting a common denominator, and you get 19 pi over 12 plus 2n pi. Now we have at least 2 solutions and a way to generate all of the rest. We're asked to find our answers between 0 and 2 pi, and since both of these are positive, if we add 2 pi to that, we're outside our indicated range. So our 2 solutions here are 11 pi over 12 and 19 pi over 12. Okay, so let's solve cosecant of x plus pi over 8 minus 2 equal to 0. So first, move the 2 over here. And this means that sine of x plus pi over 8 must equal 1/2. An inverse sine of 1/2 is pi over 6. So I have x plus pi over 8 is equal to pi over 6 plus 2n pi. Or I have x plus pi over 8. Since this is sine, it is equal to pi minus our alpha, which is pi over 8. No, pi over 6, sorry. Pi over 6 plus 2n pi. So subtract pi over 8 here, and you get that our x has to equal pi over 24 plus 2n pi, or x plus pi over 8 is equal to 5 pi over 6 plus 2n pi. And subtract pi over 8 to get 17 pi over 24. Okay. Now we want to make sure that we have all of our solutions. Both of these are positive, so if we add 2 pi, we are outside of the range we're interested in. So our two solutions are pi over 24 and 17 pi over 24. Okay, so let's talk about finding equations that involve multiple angles. So if x is the measure of an angle, then for any real number k, kx is a multiple angle. And we have to be really careful when we're finding all of our solutions involving multiple angles, because there's part of it that really gets messed up, okay? So let's find all the solutions between 0 and 2 pi. If we have sine of 2x is equal to square root 3 over 2. So I want to find sine inverse of square root 3 over 2. And that would be pi over 3. Okay, so this is alpha. I have 2x, the argument of our sine, is equal to pi over 3 plus 2n pi. Or, since it is sine, we have 2x is equal to pi minus pi over 3 plus 2n pi. Now, I need to solve for x. And this means dividing every single thing by a 2, which means multiplying that denominator by a 2 when you divide by 2. So I have x is equal to pi over 6 plus n pi. That 2 gets changed. Okay, here, do your arithmetic. I have 2x is equal to, that's going to be 2 pi over 3 plus 2n pi. And now if we divide everything by a 2, we have x is equal to, that's going to be pi over 3 plus n pi. Okay, now here, if our n is 0, we get pi over 6 as one of our solutions. If n is 1, then we're adding pi to pi over 6, and we get 7 pi over 6. If we add pi again, then we are above 2 pi. So these are the two possibilities we get from this set of solutions. Here, if our n is 0, then we get pi over 3 as one of our solutions. Not equal, those should be implied. And then if n equals 1, I add pi to this, then I get 4 pi over 3. And if I add pi again, then I'm above 2 pi, which is too large. So here we have 4 solutions. We have pi over 6, we have 7 pi over 6, we have pi over 3, and we have 4 pi over 3. Okay. Now let's solve cosecant of 2x is equal to the square root of 3 over 2. Now using our reciprocal identities, this is the same thing as sine of 2x being equal to 2 over the square root of 3, just the reciprocal of it. Now I haven't rationalized that. We can if we want to go on. But right now we have an issue because 2 divided by the square root of 3 is approximately 1.1547, which is greater than 1. and we don't get sine values greater than 1. So if you try to find inverse sine of this value, you're going to get an error because it doesn't exist. This has no solution.